Hey guys, we're going to go a little bit more into parallel circuits, but you can see that I also did a series circuit here just to talk about some of the simple things with the series circuit. So, by the way, we remember that there's only one path. So, the big rule with current is if it's only one path, it should stay the same everywhere. So, I've got a couple ammeters in there. The other idea is then that if the battery has 9 volts, that whatever resistors it goes along in this loop, this one path, it's going to lose that in total with these added up. So if they are identical, this one would actually lose 4.5 volts and this one 4.5. One major thing we learned about resistors in a series is when you add more resistors, the total resistance goes up, which means the total current goes down. You may be wondering, why would I want that? Well, let's look at the bulb brightness and look at the current. Maybe the bulbs, that's too much and they'll burn out and maybe just blow or melt. So if I actually, instead of doing a bulb, I'll do an actual resistor for you guys. If I add a resistor in here, this could actually help me reduce the amount of current because the total resistance went up. And maybe now these won't burn out. So adding stuff in series is useful. It can actually help you control the amount of current that an object would get, which is a big deal, of course. All right, parallels, on the other hand, these are completely different, and these have a lot of good uses in the house, a lot of safety things. But anyway, you'll notice the switch right by the battery. When I close that, that doesn't necessarily start the current because I've put switches in other places too. So we do need a closed circuit somewhere. So when I close the first one, this actually isn't a parallel circuit yet because if you look, there's only one path. All right, and the current's the same everywhere. If this battery's 9 volts, then this thing's losing 9 volts. All right, but I want you right now to just pay attention to the bulb's brightness and the currents when I introduce a second light bulb in parallel. Pay attention to this number mainly up here. When I do a second light bulb in parallel, the total current went up. Again, because it's that weird idea that when you add resistors in parallel, the total resistance goes down, which means the total current goes up. Okay. The bulb brightness, when I did this, funny enough, actually stayed the exact same. All right. Well, let's think about why. Well, the total current went up. And if I go the wrong way, the current right here splits. If the light bulbs are identical, it splits evenly. So each path is actually still getting what the original one was. All right. The other thing is each one of these are on their own loops. So if I put the multimeter across it, you'll see that each light bulb is actually still getting 9 volts. All right, so the rules are the current that goes in, the total 1.8, needs to still be the same as the currents coming out, which these two added up are still 1.8. So this rule with current makes a little bit more sense now. It's called the junction rule. And why it makes sense is because now you can actually see the junction where the current splits. The loop rule still applies because if I just do one loop, I only go across this light bulb, so this needs to lose 9 volts. This really throws you guys off because you think then that, well, this one got 9, how can this get 9? It's the idea again with water kind of going down a mountain, the potential energy it has. So if this is the top of the mountain, the water can take individual paths and it's still going to fall the same height. So it still has the same potential drops because it's on individual paths. All right, you will notice though that the light bulb brightness again did not change. All right, so what actually happens with this is since it now draws a higher total current, it'll drain the battery much quicker than this battery when I do parallel, especially if I keep adding more in parallel because that's again going to make the total current get bigger and bigger. What are the advantages of this if it then makes the battery drain quicker? Well, first and foremost, if you have an object in your house that you want to run at a certain voltage, 9 volts, connecting other devices in parallel won't affect that. It'll let it shine at the same brightness or work at the same power that you want it. The other thing is then in the house, if I actually want to turn a light off in the house while keeping another one on, I can just open one switch and the other one is on its own individual path. There's also safety things with this, like circuit breakers in your house. If you know that, I don't know, the blow dryer or something is drawing too much current, it can just blow that fuse and keep the other stuff in the house running. All right. A lot of more uses out of this. I won't go into all the details, but I'm going to get to another video where I actually kind of do an example with the math. But the best rule is if you do one loop, this is going to be the same voltage drop as the battery. And that's my starting point with parallel circuits. It makes them a lot easier.